Hello guys, Assalamu alaikum. Welcome back to all of you in my new video. In this video, we will be talking about representation of data, text, images, and sound. This is chapter number 1 from your O-level computer science book. So, there are different types of data, text, sound, and images, and video, and a lot of other types. So, first type of data is character set. So text is a collection of characters that can be represented in binary, which is the language that computers use to process information. To represent text in binary, a computer uses a character set, which is a collection of characters and the corresponding binary codes that represent them. One of the most commonly used character sets is the American Standard Code for Information Interchange, which assigns a unique 7-bit binary code to each character, including upper, lowercase, digital, punctuation marks, and control character. The ASCII code for the upper letter is A is 01000001, while the code for the character question mark is 00111111. ASCII is having some limitation in terms of the number of characters it can represent, and it does not support characters from language other than English. To address these limitations, Unicode was developed as a character encoding standard that allows for a greater range of characters and symbols than ASCII, including different languages and emojis. Unicode uses a variable length encoding scheme that assigns a unique code to each character, which can be represented in binary form using multiple bytes. For example, the Unicode for the heart symbol is U plus 2665, which can be represented in binary form as this. As Unicode requires more bits per character than ASCII, it can result in larger file size and slower processing times when working with text-based data. Next type of data is sound. Sound is a type of analog signal that is captured and converted into a digital form to be processed by a computer. To convert sound into digital form, a process called sampling is used. This involves taking measurement of the sound wave at a regular intervals and when converting these measurements into binary data. The quality of the digital sound depends on the sample rate, which is the number of samples taken per second. A higher sample rates results in a more accurate representation of the digital sound wave, but it also increases the file size of the digital sound. For example, a CD quality digital sound has a sample rate of 44.1 kHz, which means that 44,100 samples are taken per second. The sample resolution is another factor that affects the quality of digital sound. This refers to the number of bits per sample, which determines the level of details and accuracy of each sample. A higher sample resolution results in a more accurate representation of the sound wave, but it also increases the file size of the digital sound. For example, a CD quality digital sound typically has a sample resolution of 16 bits, which means that each sample is taken or is represented by a 16-bit binary number. There are two types of file sounds, sound file, MIDI or MP3. MIDI means musical instrument digital interface, and it stores a set of instructions for how the sounds should be played. It doesn't support the actual sounds. Data is the in the file has been recorded using digital instruments. It specifies the notes to be played. It specifies when each note plays and stop playing. It also specifies the duration of the note, volume of the note, tempo, and the type of instrument. Individual notes can be edited. Second type of sound file is MP3. It's the most commonly used and saw. We usually saw this type of file. It's a format for digital audio. It's an actual recording of the sound. It's a lossy compression format. It is recorded using a microphone. Next type of data is images. So, a bitmap image is made up of a series of pixels, which are small dots of color that are arranged in a grid. Each pixel can be represented by a binary code, which is processed by a computer. The resolution of an image refers to the number of pixels in the image. Higher resolution means more pixels and is therefore sharper and more detailed, but it also requires more storage space. The color depth of an image refers to the number of bits used to represent each color. A higher color depth means that more colors can be represented, resulting in a more realistic image but also requires more storage space. For example, a 8-bit color depth allows for 256 different colors to be represented, while a 24-bit color depth allows to over 16 million different colors. The file size of an image increases as the resolution and color depth increase. This is because more pixels and colors requires more binary data to represent them. The quantity of an image also increases as the resolution and color depth increase. However, it's important to balance the desired quality with the practical limitation of a storage space. Data storage. Data storage is measured in a variety of units, each representing a different size of storage capacity. The smallest unit of measurement is the bit, which represents a single binary digit, either 0 or 1. A nibble is a group of 4 bits, and a byte is basically the group of 8 bits. Then KB bytes, then MB bytes, GB bytes, PB bytes, EB bytes, and XZ bytes are all larger units of measurement. Specifically, a KB byte is equal to 2 raised to power 10 bytes. A MB byte is equal to 2 raised to power 20 bytes. A GB byte is equal to 2 raised to power 30 bytes. A TB byte is equal to 2 raised to power 40 bytes. And a PB is equal to 50 and so on. How to calculate the file size of an image? First step is you have to determine the resolution of the image in pixels, which is width multiplied by height. Then you have to determine the color depth in bits, 8 bits for 256 color. Then you have to multiply the number of pixels by the color depth to get the total number of bits. Then you have to divide the total number of 8 bits by 8 to get the final size in bytes if it's required in bytes. If necessary, you can convert the larger unit like KB bytes, maybe bytes, etc. And here you can see that we have an image measures 100 by 80 pixels and has 128 colors. So this must be used 7 bits. So we are just going to multiply, say 100 multiplied by 80 multiplied by 7 because we have 128 colors. So 128 can be represented in 7 bits. Then we will be dividing bits into 8 to convert bits into bytes. Then dividing 1024 to convert into KB bytes. How to calculate the file size of a sound file? First, we have to determine the sample rate in hertz. Then we have to determine the sample resolution in bits. Third step is determine the length of the track in seconds. In the fourth step, we will going to be multiply the sample rate by the sample resolution to get the number of bits per second. In the fifth point, we are going to multiply the number of bits per second by the length of the track to get the total number of bits. And at the end, we will be dividing the total number of bits by 8 to get the file size in bytes. And if you want to convert into larger units, we can do it. See, sound clip uses 48 hertz kilohertz sample rates, 24 bits resolution, and is 30 seconds long. So we will be multiplying all those things and then they multiplied by 24, 48,000 hertz multiplied by 24, and we got bits per second multiplied by the sample uh, taken in 30 seconds, and then dividing by 8 to convert into bytes, and then to divide 1024 to convert in larger units. In exams, they can ask you this type of a question that in an image has a resolution of 600 multiplied by 400 and a color depth of 1 byte. Calculate the file size of image, giving your answer in bytes. So, compression. Compression is basically reducing the size of a file. This is done to reduce the amount of storage space it takes up and to reduce the bandwidth when sending a file. There are two types of compression: lossless compression and lossy compression. Overall, compression is necessary to reduce the size of larger file for storage, transmission, and faster processing. The choice between lossy and lossless compression depends on the type of file or its intended use. Lossy compression is generally used for media files when minor data loss is acceptable, while lossless compression is used for text, code, and archival purposes. So there are two types of compression: lossless and lossy. Lossless compression algorithm is used to reduce the file size without permanently removing any data, while lossy is used to reduce the file size by permanently removing some data from the file, and we cannot recover that data. Lossless repeated patterns in the file are identified and indexed. On the other hand, in the lossy method is used for images and audio file where minor details or data can be removed without significantly impacting the quality. Lossless compression data is replaced with the index and position stored, and the number of times the pattern appears is also stored. Lossless compression is used run length encoding technique and Huffman encoding are used, whereas the lossy compression used downsampling, reducing resolution, color depth, and reducing the sample rate or resolutions are used for lossy compression. RLE replaces sequences of repeated characters with a code that represents the character and the number of times it is replaced. Huffman encoding replaces frequently used characters with shorter codes and less frequently used characters with a longer codes. In a lossy compression, the amount of data removed depends on the level of compression selected and can impact the quality of the final file. So in this way, how RLE works, this is one of the image. Width is 10 pixels, height is 6 pixels. So multiply 10, multiply 6, multiply 8. So the color depth is 8. So 480 bit is used to represent this image. Then we have just calculated number of bits: 8 whites, 2 yellow, 4 whites, 1 black, 3 whites, 2 yellow, and so on. This data can be used like 8W. 8W means 8 white, 2 yellow, 4 whites, 1 B, 3 white, 2 yellow, and so on. So here you can see that at initial we were taking 480 bits to represent this image, but now we are using just 320 bits to represent this image. So it's almost we are using at least we are saving 30 to 40 bits to save our data. So in this way, lossless compression work or the RLE works. If you have any question, comment below. I would be happy to answer your question. Thank you so much.